In SolidWorks, you don't always need to use a single guide curve for making sweeps. You can use as many guide curves as you want. Now in this case, I have this profile, path, and two guide curves which I'm going to use. So let's go to Feature, Sweep, and I'll start with a profile and then path. Now I'll go to guide curve and I'll select the first guide curve here. And as you can see, as I selected the guide curve, SolidWorks will make this 3D shape closely resembling the guide curve here, but in these areas, as you can see, it's moving away from the guide curve. It's not able to completely follow the guide curve. Now, if you want to, you can select one more guide curve here, and now this will follow the guide curve as well. But again, we have a problem. Just look at this from this perspective. So here it is following the two guide curves which we selected, but in this direction, you can see that it's still not following this guide curve perfectly. So if you want, you can add two more guide curves which are similar to this one to make a perfect kind of shape. So here I'll cancel out this and let's add two more guide curves. So the first thing that I'm going to do is I'll delete this sketch, the last sketch, and I'll delete it. All right, now let's go to sketch and I'll select one of the planes of these existing sketches. So in this case, I'll select the right plane, which is the plane of this sketch. All right, with that selected, I'll go to arc and I'll just create an arc like this, and we need a couple of dimensions. So here I'll add this, it is 60, and then we have this distance, the horizontal one, that's 75. Also this point, and this one, they're all horizontal. Now this point and this one, it's vertical. And finally, we just need to ensure that this distance is 15. Which it is, so we don't need to add it. So with that, we are now ready to add the next one. So this is added. Let's exit out of this sketch, and now I'll just use this one as a reference. So I'll go to sketch, and here I'll select the front plane. There we are. And once again, I'll go to arc. So here and here and here, and we'll repeat the process. So here again, this should be 60, and these 3 points are perfectly horizontal. These two are vertical, and the distance, that's 75. So with that, this distance is again 15, but if you want to check, you can just apply it here. As you can see, we don't need to add it. Obviously it's going to over constrain it, but we did that just to check it. So we have this again here perfectly added. All right, and now we have 4 different guide curves which we can use. But before that, let's add our sketch profile. Now for the sketch profile, I'm going to use the rectangle tool. So I'll go to rectangle and I'll select 3-point corner rectangle. Now let's go to the plane, and in this case, top plane is the one which we need, and I'm going to select 3 points here. So the first point, the second point, and the third point, they're all selected. But that's not sufficient. These 3 points are coincident, but not this last point. As you can see, there is a gap here. We need to ensure that these 2 points are coincident too. So I'll select this point and this one, and I'll select coincident constraint here as well. All right, now with that, all of these points are now coincident, and we are ready to use it in our sweep profile. So let's, for a moment, check this one. Okay, that's also coincident. Exit out of this sketch and let's go to feature and sweep. So we have this sketch profile. This one is path, and now go to guide curve, and now we can select the first guide curve, and we have the second one here, and we have the third one, and we have the last guide curve. And as soon as you selected all the 4 guide curves, this 3D profile will once again show up. So there we are, we have got this 3D solid which is created with 4 guide curves in this case. And now it is symmetric from all the 4 sides. So here it is, it's perfectly symmetric, and here also it's symmetric. So that's how you can use several guide curves to create this kind of sweep geometry. Let's see one more example here. So I'll go to window and I'll select the second drawing. Now here also we have 2 guide curves, and as you can see, these 2 guide curves are completely different. This one is made with an arc and this one is made with a spline, and this thing is an ellipse. It's not a circle, obviously, because if you use a circle here, the 3D geometry will fail, because in this case the diameter is changing here and also here. So diameters are changing in both the directions, which is not possible for a circle. A circle cannot keep up with these kind of changing shapes. So I'll go to sweep now, and here again I'll start with sketch profile and then path. Now we need to select the guide curve. So go to guide curve and let's select this first one, and this is what we have. So with this guide curve we are going to get this kind of shape which will follow this curve exactly. Now we'll also select this guide curve. Now as soon as we select this guide curve, from this direction also it will follow that curve. So there we are. So from this direction it's going to follow that curve spline, and from here it's following that arc, and we are going to end up with this kind of 3D solid, which is otherwise very difficult to make with simple tools. Now before we finish this part, let's analyze it, and you can analyze it using this curvature display. So here we have some options like mesh preview. You can activate it, and with that you can see this using all these meshes. So this one is UV curve, which you can use to visualize the cross sections here, and right now we only have 3 of these, so you can increase the density kind of like this. So this is a tool to visualize the way this curve is made. So here you can see how this curve is flowing here in the vertical direction and how it's moving here in the horizontal direction using these UV curves. So that's an inspection tool. Also we have the zebra stripes. So I'm going to deactivate mesh preview and activate zebra stripes, and using this once again you can check the areas of high stress concentration and also areas of deformities. So everything is kind of clearly visible here, so using zebra stripes. And finally you can also activate the curvature combs, and using this once again you can check the points where the curvature is changing for these surfaces. So to understand this, I'll first deactivate this direction 2, and I'll only keep direction 1 active, which is this red lines here. Now in this set of red line you can see these lines on this cross section here, and the length of these red line is inversely proportional to the radius. So the longer these red lines are, smaller the radii here. So as you can see here we have a smaller radius, so longer red lines, and then whenever we have larger radii the red line is smaller. To analyze it properly, you can increase the density of these red lines kind of like this, and with increased density you can see it clearly. Also in this case mesh density is really high, so I'm going to decrease this further so that we can analyze it clearly. So there we are. Also you can see the inflection points. These are the inflection points where curves are changing their direction. So there are several things that you can actually analyze with this. Now if you want to activate the second direction, also activate it, and there we are. We can once again see this here in this direction. So here also it's the same thing. The direction of these blue lines, it's always perpendicular to the surface. So here it's moving downwards, which means this is exactly here perpendicular. So if you make a tangent here, this line is going to be perpendicular with that. So with this way you can actually see where the direction of these surfaces are flowing. So that's an analysis tool. Here also you can increase the scale. If you want these lines to look bigger, you can increase the scale or decrease it, and also you can increase or decrease the density to see it clearly. Once you are done, you can uncheck these options, and finally let's click OK, and here we are. We have got the final 3D sweep.